Okay, so today we're going to be getting further into program design, specifically control, logic. This is also, it's called many things: branching, control, logic, loops, all kinds of stuff. The main thing to think about for today is a lot of you were, maybe still are, wrestling with this whole input argument, output argument thing. How do they get back and forth to each other? You know, we'll be around after class to talk more about that. Okay. What we talk about today is really not part of the whole passing arguments to the function and getting arguments back. Okay. What we're talking about today is everything that goes on inside of a function or a script. You know, you could do this in a script as well. Okay, so a lot of material at you today, relatively. Some I'll go over fast because it's the kind of thing that you can, you know, look up in your spare time. Some of the stuff is not used as frequently as others, so I'll tend to spend a little more time on things that we, and very likely you, are more likely to use with MATLAB. And some of the things are a little more sassy than, not even that, just a little more less used than others. Okay. So we start with the logical data type. Now, so far we've had variables, excuse me, just on the end of a cold, not contagious, still affecting my voice. We have talked about variables that hold numbers, and at one point I told you that's actually a type of data, because inside a matrix can go anything. And one of the, like cats and dogs, one of the things that can go inside a matrix are logical data types. They can only be true or false, only two possible values. Both the words true and false are reserved in MATLAB. In fact, we're going to just do a little experiment. I wonder, could I even override those? If I can do this, then I'm going to be very upset with MATLAB. But look, it does. Okay, so I mean, you can do anything in MATLAB. Clear. You have to be careful. All these reserved words can be overridden. You can set pi equals to 5. But we need to understand these in order to understand what relational operators are. The way that we can create a data type that is a logical data type, or again, a matrix, everything's a matrix, right? That is a logical data type is we can specify it, variable 1 equals, and instead of saying 3, 4, 153, I'll just say true, not tour, true. Oh, it's there, it's just can't see it. I move, okay, move over. Under the workspace, you see class that says logical. That means it knows that it is holding either a true or a false. You can have a whole matrix of things like that. False, true, oops. How about false, true, true, true. And now it's holding a 2x2, variable 2 is a 2x2 matrix that is holding logical data types instead of number data types. By the way, most numbers that are held, it's a little side note, if most of the time you have a number in a variable, that type is called a double, for double precision. We don't really need to worry about all the 8 bits or 8 bytes of information and all that stuff, really. For us, it's enough to say when you see double, it's holding a number. Logical, it's holding a true or a false. One thing I notice right away is if I now do an ask on variable 1 or variable 2, in fact, we already just did on variable 1, but let's look at variable 1. Variable 1 is holding the value true. Now this is just a little idiosyncrasy, one of the many, many, many idiosyncrasies of MATLAB, in that when you do an ask, it does not say true or false. It just says 1 or 0. Okay? That is just the way MATLAB prints to you, when you do an ask, it thinks, well, you don't really want the word true or false, you just want a number 1 or 0. So that's how it tells you what it's holding. It doesn't really mean it's holding a 1 or a 0. Yes. Oh, well, so variable 1 says 1, that means it is a 1 by 1 matrix, and it's holding the value true. So if we go up 1 to this variable 2, notice how I asked it by not defining it. It's holding false, true, true, true. Make sense? Okay, good question. What else? Great. Building on that, we need this to understand what relational operators are all about. Relational operators are things you already know very much about. Equals, not equals, less than, greater than. And relational operators are simply an operator that has an operand on either type. Remember, we need to know these fancy words. We can't just tell Mom that we're learning 3 is less than 4. She knows that. Okay, so talk about operands and operations, relational operators. When I type something, variable, operand, variable, let's go back and do something just like that. If I type 3 less than 4, okay, this is a relational operator, and it always returns a logical type. It's actually saying way more words than are necessary for you to get the idea. Any kind of relational operator either says yes or no, true or false. So if I say 3 is less than 4, and I hit return, that is like doing a new variable. And since I didn't assign it to anything, it's going to assign it to ANS. And that ANS is going to be what? It's a 1 by 1 matrix. And what type is it? I go up and look, and it is logical. Okay? That means that we can do crazy things like my result equals the relational operator 6 is equal to 5. Okay? So if I hit return, what will my result be? Okay, heard lots of answers. It will be a matrix, because everything's a matrix. What will be its type? Logical, or its class? Logical. And what will it truly hold? Not what will it display to me, but what will it truly hold? False. What will it display to you? Good, good. If you have those simple 4 concepts sort of ingrained, you can do fine. Okay? Let me repeat them. Well, I'm going to say about 5 or 6, I'm sorry. There is a logical data type. It's true or it's false. You can use a relational operator like less than, greater than, equals, not equals, and assign that result to something, a new variable. That new variable will be of logical data type. And though my inflection sounded like there'd be one more thing, I can't think of it. So I think that's it. Okay. Notice the difference between assignment equals and ask equals. Okay. If I want a variable to equal something, like 3, I say variable 1 equal sign 3. If I'm doing a relation operator, I want to test whether something is equal to 3, I say variable 1 equal, 2 equal signs, 3, and that's like question mark, inflection. So one is assigning 3 to the variable, the other is asking, is 3 equal to this variable? 2 totally different things, only different by 1 equal sign. Okay, let's try a couple other crazy ones. Variable 4 I'm going to make variable 4 some random numbers between 0 and 1. Okay, 2 by 2 random matrix between 0 and 1. Okay, questions you always ask yourself. What is variable 4? Answer, a matrix. What class or type is variable 4? Well, it's just numbers, so they're probably doubles. Sure enough, they're doubles. What's its size? 2 by 2. Okay, all's well and good. What if I want to do something like, let's do something different. My result 2 equals, now I'm going to ask, variable, not raviable. Boy, I've got aphasia of typing today. That's all right. Variable 4, let's see, how can we do something fun, is less than 0.5. Okay. On the right side is a relational operator, marked by the operand less than. Okay, I've got variable 4 less than 0.5, but now variable 4 is a 2 by 2. That means my result 2 should also be a 2 by 2. It's going to return a result to us for every position in that original matrix. So again, what is my result 2? It is a matrix. Of what type is it? Logical. Was it really holding? False, true, false, false. And that makes sense if you look at variable 4, which has something above 0.5, not above 0.5, sorry, I did less than. Not less than 0.5, less than 0.5, not less than 0.5, not less than 0.5. Okay. All right. All of these are building up what we need in order to really understand program flow. One is assignment, one is ask. If both variables are not scalars, then both variables must be the same size. Oh, that's a good point. Okay, so notice how this operation, variable 4 is a 2 by 2. What's on the other side should also be a 2 by 2 unless it's a scalar. If it's a scalar, then it just knows I should do that with every element by element. Let's look at that another way. Okay, variable 5 equals random 3 by 2. Variable 6 equals another random 3 by 2. Now what happens if I say variable 6 is less than variable 5? Okay, so that right there is an operation, relational operation. It should return logical values. And since neither of them scalars, they should be the same size, which they are. And that means they're going to do it element by element. So if I look here, didn't know that quick math was going to be part of the, well, that's why MATLAB is my friend. I'll just hit return and trust that in those particular element locations, variable 6 was less than variable 5 element by element. Okay, does that make sense? Now what happens if I try to do variable 6 is less than something that's not its size, like variable 2? Oh, okay, gave me an error. Sometimes it actually gives you an error. The matrix dimensions must agree. Okay, so far so good. Logical operators. So we have relational operators, we have logical operators. Logical operators also produce a logical result. So now we have relational operators that produce a logical result. We have logical operators that produce a logical result. These are a little bit simpler. This is Boolean logic. If you've heard of trues and falses and adds and ors and XORs and that kind of stuff, that is what we were talking about. Okay? Operators with one or two logical operands that return a logical result. I think some of you have probably had this before, and if you had, good for you. If you have not, there is a nice little handout logical operators, and it tells you what is the result of doing true and true. That's true. True and false is false. If you do not understand the ands and the ors and things like that, look at that table and let me know. Short circuit operation I will talk about in a little bit. You may see that phrase here and there in documentation with logical operators. It means something pretty easy, but we'll get to that in a second. Now, I could write at this point some big Bob Marley long expression that had logical operators and relational operators and maybe even some divisions and that. You know, I could write something huge. What order does it go in? Remember when you did order of operations in algebra? You know, parentheses is everything, and then it's multiply and divide, then plus and add, and all that stuff. Well, first of all, it does the arithmetic first. Okay, so if you've got mixed in relational and logical, and I want to know what 5 plus 6 is, it will do 5 plus 6 first in that long chain. Then it does the relational operators from left to right. Then it does this is called the negation operator or the not operator. Not true is false. Not false is true. It will do all of the ands from left to right. Then it will do all the ors and the XORs from left to right. Now, of course, before it does anything, it does parentheses. So really, that should have been up at the top. Anything within parentheses, it will do before combining it with others. Now, what kind of teacher talks about this and then puts, you know, this stuff on the board, you know, and then asks you to do the result? What kind of teacher is that? A what? No. A good or evil teacher? Evil. Evil. I'm surprised we didn't know that. Okay, so putting this up on the, you know, and then saying, and then almost, and you know, did you ever do this? You know, your teacher would do this to you and almost hope that you'd get it wrong, you know, or act like it? No. So we could, if I were evil, I would say, here's a quiz with, well, I actually might do this. It won't be this complicated. It won't be this complicated. Define some variables which are trues and falses, and then say, you know, what's the result of this? That's the kind of thing that, I mean, actually, you could type this into MATLAB, and there should be a way to process that and figure out the result. The point I'm trying to make was taking way too long. I'm not going to do this big stuff with you. But if I did, what would we do? We'd look at that, we'd say, okay, this not D would be first, and then B. Let's just do one. Let's say I had predefined things. A is true. I do not know how to skin it. B is false. C is true. D is false. Okay. Just to prove to ourselves that we could do this. Well, for the last time. In my thing, there's no arithmetic. There's no relational. Next thing is negation. So the first thing it does is say not D. So that's a true. Then it does the ands from left to right. So the next thing it does is say A and B. Now, A, true and false is false. And then it does the ors. So false or true is true. Okay, we can actually do that. So it's possible to do this. If I ask you a more complicated long thing than that, you can say, I don't understand the question, and I refuse to answer. Actually, you do understand the question. Just say I refuse to answer the question. You said there wouldn't be anything that long. Okay, let me stop for a second and see if you have questions so far. Yes?
So what is the difference between the true and false at the top and the bottom?
So it is, what it's doing is we are doing relational operators on these variables. I'm assuming that I have assigned, you know, before A equals true, B equals false, and so forth. And then I just literally wrote this out at the command window. What would MATLAB do? It would process these. This is a logical operator on D, which returns true, A and B, et cetera, et cetera. Is that answering your question?
Why would it return true if it's false?
Oh, it's false. The last thing it does is false or true. And false or true is a true. The logical operator or, if either is true, the result is true.
What if you put it in, like, with the squiggle, I put it in exactly like that, and it said it was an invalid use of operator?
Then it doesn't know what it's talking about. You have to put this in parentheses?
Yeah, that D has to be in parentheses.
Okay. Sorry. See, if I didn't know that, then how could I ask you guys that? There might be a squiggle operator with C, squiggle D, and I don't know.
For C,
Yeah.
you just have the true on top, but you can do anything below.
Oh, it's still here. Oh, I see what I see what I did wrong here. You know what? This is not even valid. I'm surprised that even with parentheses this works. This is something's wrong here. I didn't do anything with C and D, which is maybe what you're saying.
Yeah.
Let's do a new problem. Let's do this. That actually might work without parentheses. That's actually valid. I didn't have anything between C and D. What was it supposed to do with C and D? I don't know. That was not good with me. Now, let's do that again. It does not D first, which makes it a true. Let's just map out kind of what it's doing. C is true. A is true, and B is false. So at the first step, it has, this is all internal. It's not showing you these steps, of course. First step, it has that. Then it does the ands. True and false is false. True and true is true. That's what it has now. And now it can say false or true is true. Ah, feel much better. Yes. Why is D true? The first thing we did is we did this little not operator. So it does not false, which is true. Good, good, good. Love it. Good questions. Good questions. What? Yes. Right. That's a lot. Right. The logical, this is good. Yeah. Good, good, good. The logical operator and both have to be true for the result to be true. So both sides have to be true for the result to be true. The logical operator or, if either is true, the result is true. Okay. There is one more XOR. It's on your thing. XOR is called an exclusive OR. That's much less used, but it's valid. XOR, they both have to be different for the result to be true. True XOR false is true. False XOR true. You can see how you can, these are people who do zeros and ones in their heads all day long.
So I've like done some of this before.
Okay.
Would it be easier, I guess, for some people that aren't understanding, just like a truth table showing?
Yes. So that is what actually that logical operator thing is. Yep. Well, actually, since we brought it up, this is not actually in truth table form. It just says for all the options, true and true, true and false, false and true, false and false. For example, for and, what the result is. Now, there are these things called truth tables where they just say, okay, let's say you're doing A and B. Okay, so you make this, if A is true, if A is false, compared with if B is true, if B is false. Okay, this is called a truth table for the and logical operator. And what you do is you fill this out by saying, okay, the results, true, true is a true, false, true is a false, false, false is a false, Oops, true, false is a false. False, false is a false. So that's called a truth table. This is the same information. If you ever see a truth table, it's the same information that's on this list. Very good point. Very good point. Okay. All right. Now that we know all about logical operators, relational operators, and the main thing is that they return logical values. Now we can do program control. Program control is basically telling your function when to do something, when not to do something, telling it to do specific blocks of code, don't do specific blocks of code, and sometimes it's called under different categories. So, for example, we have something called conditional control, which is a fancy name, which means maybe do it. That would be the if statement or the switch statement. We have something called loop control, which forces it to go through a loop of statements a set number of times. That would be the for loop, the while loop, and we have some keywords in there called continue and break, which tell us whether we're going to stay in the loop or not. Now, all of these, of course, we're going to go through each one, and I'm going to tell you which ones are used more and which ones are hardly used at all. This one is not used as much, it's not going to be on your homework, but is very useful for people who write a lot of MATLAB functions. It's called a try-catch. I'll briefly talk about it. You won't have to know it. And program termination return, which is something that most of the time we shouldn't do. So we'll talk about all of those things now. So now to illustrate this, with all these things, what I'm going to do is, just so you know beforehand, here is that sample code, which is on Canvas. And there's several blocks of statements we can run. Don't worry that there's some yellowed out stuff and that it says creating live, this can't be a live script. Don't worry about that for now. That's not the purpose. Okay, so we're going to go through some of these one at a time. First of all, the if statement. The general form of the if statement is here. It basically tells MATLAB if you want it to do something, and if not, should it do something else, or just don't do anything at all. Okay. In all of these examples, where you see expression 1, expression 2, that is going to be either a relational operator or a logical operator. Since they both return logical values, and since logical values can only be true or false, then it makes this a little bit easier to read if you just keep that in mind. Anytime you see expression something, it's just going to be a true or false. So this is going to reduce to, if true, then do these statements. Else if something might be false, do these statements, et cetera, et cetera. Okay, let's go on a little bit. And the best way to do is do the examples. So in each of these, I have little blocks which have sample whatever. Okay, and these are probably not too hard to read. All of these are within a script. Is this a script? Sure enough. In fact, it nicely says script. So I define a couple variables and then I say if. So what comes right after the if must be a logical value. Must be a logical operator or relational operator. This one turns out to be a relational operator, but includes some arithmetic in it. That's okay, because arithmetic coupled with relational operators is still a true or a false. Okay, so you can see it's going to see how much time you took, and then if you beat 10 minutes a mile, you do this. If not, then you can put something in there. This is optional, which is called else if. This is used if you want to do something possibly else in case the first condition wasn't met. So if you did not beat 10 minutes a mile, it will go to the else if. Check that. That will be another relational operator. Oops. If not, it will do the else, and then it will come down to end. Okay, so a couple notes about this. If this is true, like if runtime divided by run distance was really less than 10, it's not here, but if it was, then it would execute this thing and then go right to the end. It wouldn't go to any of the else's. Likewise, if runtime less than run distance was not less than 10, it would go to the else if. If that were true, then it would do this display and then jump right to the end. It would not go to the next else. Having an else in there says, if nothing else, then do this. Both the else if and the else are optional. I could have just if something, do the statement, end. That's perfectly valid. That just means you want to do that something only if the thing was true and you wouldn't want to do anything otherwise. Okay, so if we run this, and by the way, you can go to any script and you can highlight and you can press F9, magic function key, and then go back to the command window, and it should have done it. It didn't do it here because, I don't know. Let's try that again. Maybe on my computer to do function, I actually have to hit function F9. There we go. So it did it. Okay, so I printed out those statements. It actually went through. Apparently, I'm not doing very well with the running. All right, that was pretty quick, but questions on that? Yes. Yes. If you have more than 3 options, would you do else if? Yes. There may be a better way, but certainly more else ifs are fine. How come I can't get, here we go. Oh, okay. Notes on if. What if that thing you put after if is not a scalar logical value, but a matrix logical value? So maybe you compared 2 variables, they were both 2 by 2, and so your result is a matrix of logicals. Well, then every value has to be true for the entire expression to be true. Short-circuiting behavior, now we get to that. What is short-circuiting behavior? Short-circuiting behavior will stop a logical expression from continuing if it can tell right away if something is, what the result is going to be. Not crucial for this class, but may be helpful to know. So for example, why might you do that? Okay, can you see what I've written? If d is not equal to 0 and c divided by d is equal to 10. Okay. Think back to order of operations. What's going to happen first? Anything arithmetic. So it's going to take care of, oh no, that's not true. Sorry. Forget about the arithmetic operations. Let's just talk about short-circuiting. For an and to be true, what has to be true? Both this has to be true and this has to be true. Now, if MATLAB goes through and it evaluates this, and let's say D is equal to 0. Then right now this returns false, and it knows it doesn't have to check anything else because it knows the answer is false. So MATLAB won't get to this C over D, which would produce an error because D is 0. I wonder if I've confused you more or if it's good. An OR statement like A or B, if MATLAB sees that A is true, it knows that A or B is true. It doesn't matter what B is. So it doesn't even need to go on and evaluate B, and it might not. That's short-circuiting behavior. Okay, here's an example. If, same thing. If A greater than B is false, C greater than D is not evaluated. It just saves computer time. Okay, moving on to the next one. This is switch. This is good for if you do have a lot of different options and only one of them is true. Okay, and here's the form. You have switches, cases, case expressions, and statements. This is much easier if we just go right to the example and look. So I'm going to scroll down here. Someone's doing some very interesting interpolation. And the interpolation could be bilinear or cubic or nearest neighbor or something else. If I say method equals and then I have something in quotes, I actually have a matrix of a whole different type, right? We have doubles, we have logicals, but remember we also have characters, C-H-A-Rs. So this would be a character variable. If I switch on this method and I have lower in front of it, which all it does is it takes some string and make it all lowercase. So lower method is now the word bilinear, all lowercase. It goes to where it finds a case that includes bilinear, and then it does that statement. Okay? It does not have to, the case expressions do not have to have more than one thing to be true. Like this first one means it'll do this if it's linear or bilinear. But this is case cubic, this is case nearest. There's an otherwise that is optional, doesn't have to be there. But let's say you want something to be done, no matter what. Then you'd put the otherwise in here. And then if this method was some crazy name, super interpolator, none of these cases would match and it would just do the otherwise. Okay? Question on that. So if I do this, what's going to happen? It's bilinear, so it should say method is linear. Function F9. Come back here. Method is linear. All's good and well. Love it when it works out how I think it's supposed to work out. That makes teaching much easier. Switch is a little less used than the others that we talk about. Notes on switch. Each case can have one or more options. This will make no sense to you unless you have previously done programming in different languages like C that have switch statements. Switch does not fall through. So in some languages they have a switch, and then at the end of every set of cases you need to have something called a break. Switch is not like that in MATLAB. So if you don't understand that, you don't need to. For loop, besides if, the for loop would definitely be the logic control thing most commonly used. Okay? It is just going to loop through a set of statements a set number of times. Okay. Also best gone to the example. Okay, sample for loop 1. It creates a matrix that's just a bunch of zeros. Most boring matrix you ever saw, 5 by 5 matrix of zeros. Then it does 2 loops. And these are nested. Whenever you have one for loop inside another, it's called a nested loop. So it's going to range, iRow will range from 1 to 5, iCall will range from 1 to 5, and the first time through, iRow will be 1 and iCall will be 1. And it says if 1 equals 1, equals, that's a question. Does 1 equal 1? Why, yes. So it will do the thing in the if, and it will change that first row and first column to hold the value 1. Then it's end the if. Now it says end the for. That means go back up to the for and do the next one. Now iCall is 2. iRow is still 1. iRow is 1, iCall. 1 equals 2? No, don't do anything. End, end. Go up again, 4. iCall equals 3. It keeps looping. 3 is not equal to 1. 4 is not equal to 1. 5 is not equal to 1. It goes to the end, and now iCall is finished. There's no more values. The vector here is 1, 2, 3, 4, 5. So now what happens? It goes to the end of the first for loop. Now iRow will jump to the next value, which is 2. And now it will repeat another for loop with iCall. Start over, iCall 1, 2, 3, 4, 5. So when it goes through all this, it's going to do it 25 times, right? 5 in the outer loop, 5 in the inner loop. And this statement will only be true if the row is equal to the column. So you start with a 5 by 5 matrix of zeros. It goes through this 25 and looks at every element, and it only changes the one where the column is the same as the row, which means those that are on the diagonal. So when all this is said and done, that I matrix should be zeros with ones wherever iRow equals iColumn. Let's just do that and see what happens. Nope. Okay, it copied this down, it did it. Now I matrix is holding something. It started out just being all zeros, and now it has ones on the what's called the main diagonal, or where iRow is equal to iColumn. Okay, questions on that? Here's a good question for you. Even though I matrix is showing me ones and zeros when I asked what it was, is it a logical type matrix? No, it's not. If I had to check, I would go and look and say I matrix, it says double. Okay, so I didn't assign it trues and falses. I assigned it real number, or not real number. I assigned it actual numbers, and so that means it's not a logical case. Next example. Now we look a little more closely at this for loop. This is a single for loop. It says for the variable equals, and this here needs to be a vector. Okay. Every time it loops through, the variable s is something different. The first time through, what is it? It's 1. It displays a 1. The next time through, what is it? Well, it's 1 stepping downwards by minus 0.1 to 0, so the next time through it's a 0.9. Then it's a 0.8, then it's a 0.7, and so on until it gets to 0. Main message, this looping, it doesn't have to be 1, 2, 3, 4, 5, 6, anything like that. It can go backwards. In fact, we're going to see that that vector in the for loop is very flexible. See how it just, you know how you like to do on Wednesday evenings, print out 1.9, 0.8, 0.7. That's kind of like fun. So here's a way to do it. Number 3, getting sassy. Oh boy, what are we doing here? I want to start with the for loop. I'm going to jump to the for loop, okay? For mind your syntax. Look at your syntax. For this will be the variable name that will change with every iteration of the loop. Index will be something different every time through the loop. What will it be every time through the loop? That's where this, on the other side of the equal sign, is very flexible. It only needs to be a vector. How many times will the for loop run? The same as the number of elements in that vector. Right now we see there's 1, 2, 3, 4, 5. What values will index be in the loop? It will be the value of those elements in the vector. So the first time through the loop, index will be 1. Second time through, index will equal 3. Next time, 4. So you can see how it's very flexible. We don't need index to run consecutively. Yes? You know, I don't know what it would do. That's a good question. So, oops. One, 3, 2, 4. It's exactly what it did. Nice. I learned that myself just now. That's kind of nice. That's kind of sort of what you might expect, the whole linear indexing thing. Works out. Okay. And notice how the other thing is this for, most times you write a for loop, the majority of times you want the thing to run n number of times. And so you write for I equals 1 colon n. That's the most popular kind of for loop. But I don't have to do that. 1 colon n is just a vector. 1, 2, 3, 4, 5, 6, all the way up to n. I can say for index equals these indices. These indices must be some vector, and sure enough, I had just defined it. Now we go down and see this. It's printing out the values of, well, it's not printing. It's got another vector called vector fun, which is random numbers. And then it says it will print out the value of certain indices of the vector. So that's a nutso one, but you know what? Let's just run it and see what happens. Notice how it looped through an index 1, 3, 4, 9, 6, just like the indices in the M file. And then it must have picked out the first, the third, the fourth, the ninth, the sixth element of the crazy random vector. Excuse me. Okay, questions on that?
So what is it actually in this case? Why is it showing?
It is showing them because of my fprintf statement. That's a very good question. This fprintf statement is printing out what I wanted to print out, which turns out to be two numbers, the index and the value of the vector at that index. Good question.
So the index is just an arbitrary number.
Yep. I just defined it up here, this 1, 3, 4, 9, 6. So it loops through those indices, and it is a different number every time. Good, 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 good. What else? Okay. The rest of it we can go through fairly quickly. Yeah, we did these examples. The while loop is kind of like the for loop, except you don't know in advance how many times the while loop is going to iterate. It's a fancy name for loop, iterate, iterator. So a while loop will iterate as long as this expression returns a true. Now, if you don't want the while loop to iterate infinitely long, what must happen? Something about this expression must change within these program statements that follow, right? If you come to a while loop and it says while 1 is less than 2. Do these statements. It will never break out. 1 is always less than 2. So if a while loop is written, it should have something that is going to change. So for example, here's a boring loop. Count is equal to 0. It says while count is less than or equal to 10. Well, right now at the beginning, we know count is less than or equal to 10. 0 is less than or equal to 10. So we'll do the statements. The main thing is I should change count somewhere in this list of statements. It so happens that I do. I increment it by 1. And you can see what's going to happen. Count is going to increase to 1, to 2, to 3, to 4. When it gets to 10, it'll still be good. And then count will be 11, and it'll say, while 11 is less than or equal to 10. It's not. It will break out. So this should just display the values from 1 to 10, if it's working correctly. Function F9. Oh, thank you. I was just checking to see if you were paying attention. Ooh! You know how you like to print out the numbers 1 through 10 or whatever on Wednesday at 5 o'clock when you've had a good full day of classes already? Now you know how. Good stuff. Good stuff. Okay. Notes on while. Same thing with for. No, same thing with if. If expression is a matrix, then every value should be true. If it's short-circuiting, these two are nothing new with these two at all. Okay. There's ways to exit the loop before the loop is done. There's 2 things you can do. Well, two controls. One is called the break. If a break statement's encountered in the body of a loop, the execution of the loop will stop. It will jump to the end, and it will bypass the loop completely. Okay, so let's look at that for a second. Sample break statement. Come on. Here's a for loop. The variable index is going to vary 1 to 5. So the loop is going to run 5 times. Maybe, if there's no break statements in it. So for index equals 1 to 5, the first time through it's 1. If index is 3, is 1 equal to 3? No, it doesn't do anything, jumps to end, it prints it out. It jumps to the for loop. Now index is 2. Is 2 equal to 3? Nope. Jumps again. Index is 3. Is 3 equal to 3? Yes. The next thing it sees is break. So it breaks. What does it break out of? This for loop. You encounter a break, it breaks out of whatever for loop or while loop you're within. Okay, so what's going to happen here? It won't go through 5 times. It goes once, it goes twice, and now index is 3, and it breaks before it prints. So I'm predicting that it's going to show a 1, a 2, and then display I'm done. Boy, I'm on the spot here. No count equals 0 to include in this one. Ooh, yes. You know how you like to print out a few numbers? Continue is something close but not the same thing. If you see a continue in a loop, it jumps to the end, but it doesn't jump to the end of the whole for. So it doesn't stop doing the for, it just goes back into the next iteration. Okay, so the current one stops and then it goes back through and starts again. So easier to see than to explain. Here's almost the same thing, but instead of a break, we have a continue. So now what happens? It's 1, 1's not equal to 3, so it prints it out. Now index is 2, 2's not equal to 3, it prints it out. Now index is 3. Does 3 equal 3? Yes. So it continues. Now continue means bypass anything else. So don't print it out, go right to the end, but now don't jump out of the loop, go back and now index is 4. And then it will be 5 again. So with this one, I predict that it will print out 1, 2, 3, 4, 1, 2, 4, 5, and be done. Love it when it works out. It's good. Good. Any questions? Yes. Absolutely. Oh, you just wanted to read it again? Yeah, okay. What else? Other questions? It's the hardest question because it might be on your homework. You might not. Let's think of another example. Let's say, trying to think of a good example. Maybe you want to do things only if you're bringing in people randomly, students, and you want to think about whether they'd be good volleyball players, okay? Or whether you want them on your volleyball team. So in your MATLAB program, which you're using to evaluate volleyball players, you have kind of something in your mind where you're going to bring them in and you're going to say, if they are, let's say it's a women's volleyball team. So you're going to say, if they're women, and then if they are over 6 feet tall, then I'm going to do all these evaluations on them. If not, I'm going to say goodbye. So let's say you have 20 students to loop through. And so you bring them in one by one and you say, if you are a woman, true, okay. If you are over 6 feet tall, or if you are not over 6 feet tall, then continue. You say goodbye. You don't need to do any tests on them. That was a contrived, convoluted, I don't know. How was that? You're not happy because you can't, you say, yeah, but that's volleyball and we're talking about MATLAB. I know. Work with me. No, that's a good question. What else? Try catch is error handling. Like I said, we are not going to do it. You should just know about it. Why would you want to do try catch? You may suspect that some of the program statements you're about to write are going to produce errors. Maybe because it relies on user input and users are notorious for entering in, things they're not supposed to. Like you may ask, what is your name? And you say, okay, if this joker puts in a number, then catch that and do something else. Return ends the program no matter where you're at, okay? Generally, it's not the best programming practice in a main routine. It's okay in subroutines, but that's the subject of a different lecture, so we're going to put that off for now. You should know that it's there, and MATLAB recognizes it perfectly, and you could use it. Yes. Okay. That might be it. That's it. Questions? Okay, the TAs and I will stick around a little bit for questions. You have a new assignment, assignment 5. Look at it, ask questions, and we're sticking around for assignment 4 if you want help with that.